In the previous session, I started briefly talking about ordinary differential equations. Just a reminder, an ordinary differential equation is something that will be in the sort of dy by dx. معناتها we have a differentiation part in our equation. And let's say, for example, plus x is equal to 3. All right. So this is what is known as a differential equation. The way you would solve such an equation is the first step you're going to do is separation. Separation meaning that we want to separate the dy by itself and then separate this from the dx, which is here, and have it also separate. This is what separation means. So how are we going to do that? The first step here, you're going to keep dy by dx by itself on one side. So it's going to be dy by dx is equal to 3 minus x. What I did is I took this x over here and moved it to the other side. So that's our first step. Our second step is moving our dx towards the x. So, or in other case, we're going to be moving this into this side of the equation. So it's going to look like dy is equal to 3 minus x times dx. All right. Once you have dy by itself and dx by itself, and also all the x variables with dx, يعني بما معناه this x is next to dx, and there is no y in this example, but if there is a y, it should be next to dy, and we'll see that in a bit. Once you are in this phase, you're going to go to the second step, which is integrate both sides. Both sides. How would you do that? You just do the integration. So the integration of dy, this is also the integration of 1 يعني times dy. All right, so it's the integration of 1 is equal to the integration of 3 minus x dx. All right, and then you just do your integration. So for 1, a constant, the integration of a constant is simply just y equals, why is it y? Because here we have integration in terms of y, because we have dy. معناته the integration will be equal to y. In this case here, we have integration in terms of dx. So first value is 3, which is a constant. The integration of 3 is 3x minus the integration of x, which is x squared over 2. And then you're going to have your plus c at the end. All right. And now this is basically your finalized form of your equation by solving this differential equation, which is dy by dx plus x equal 3. Solving this has gave us this final answer. In this case, we have a plus c, all right, because we were not given any initial conditions. What does that mean? An initial condition is basically a value that is given for x and y at the beginning, something like y equals to 2 when x is equal to 1. These are known as initial conditions. If you are given initial conditions, the idea of it is to solve for c. معناته تبون تطلعون value for c. You don't want to have a constant here anymore. You want an actual number instead of c. How would you solve for this? So you would plug in these two values for y and x. So the y value 2, you're going to be plugging into y, and your x value, you're going to be plugging into x. So if we take this, put it over here, for y, we are going to be putting a 2, and for the x values, we're going to be putting 1 over here and over here. So the equation will look like 2 is equal to 3 times x, which is 1, minus x squared, which is 1 squared, divided by 2, plus c. And now you can solve for the value of c. So you're going to have 2 is equal to 3 times 1 is 1, minus 1 squared is just 1, over 2 plus c. Take everything to the other side. You will have 2 minus 3 plus half is equal to c. معناته our c is equal to 2 minus 3 plus half, which is minus half. Okay? And now you can plug back the c into the original equation that we solved for. which is this equation. Let me put it back here. All right. So you're going to be plugging in your C value back into this original equation over here. And that will be your actual final answer in the case when initial values are given. So this is going to be minus half. Okay? This is the whole idea. The idea is, again, we first separate our dy and dx. Once you separate them, you group up your x with the x values. Basically, in this case, it automatically happened. And your dy with your y values. We don't have any y values in this example. Once you have grouped them up this way, you're going to integrate both sides. يعني بتسوي الانتجريشن يسار ويمين. At the left side, it's dy, so the integration is in terms of y. And on the right, it's in terms of x. So once we do our integration, we will have our general form. This is a general solution. يعني بما معناه the solution has the letter C in it. If you are not given any initial conditions, that means this is going to be your final answer. If in the case where you are given initial conditions, such as here where you are given a value for y and x, you will try to solve for C by plugging in your values back here. All right, so once you plug in your y value and your x value, you will solve for C. You get a value for C, and then you will put it back into your equation, and this will be your final solution. Let's look at another example. Let's look at something like this, where we have 2t minus d theta by dt is equal to 5. All right. Again, the steps do not change. Your first step will be separation. Separation meaning you want d theta by itself and dt by itself, each on one side of the equation. All right. And all your t values should be on the side of dt, and all your theta values, if any, should be on the side of d theta. So how would we separate this? The first thing you can do is you can divide both sides by 2t. So the idea is you want d theta by dt to be on its own at the very beginning. All right. So first, separate d theta by dt. That's your first step. So how would you do that? T minus d theta by dt is equal to 5 over 2t. This is your first step. So what did we do here basically? We just divided both sides over here by 2t and 2t. That's what we did. All right, so the t's will cancel here and you will remain with 5 over 2t on the right side. بعدها, you have t minus d theta by dt. So you can take the t to the other side. So you will have minus d theta by dt is equal to 5 over 2t minus t. Okay? Here we have a negative value. معناتها it's the same as saying this is minus 1. So what can we do now? We divide both sides by negative 1 and negative 1. All right? Or you can say multiply both sides by negative 1 as well. It's the same thing. This will give us d theta by dt. And then the minus 1s will cancel over here. And you will have minus 1 for the first one. So it's minus 5 over 2t. Minus 1 and minus t becomes plus t. Okay? Now that you have this equation, you have noticed that d theta and dt is by itself on the left and right side. So what do we do now? Now we move our dt to the other side, and we will have d theta is equal to minus 5 over 2t plus t times dt. And now we have d theta by itself and dt by itself. We make sure that any variable t is next to dt. In this case, all of it is. And any theta, if in the equation, in this case there isn't, is next to d theta. And that's it. So how would we solve this now? We go to step 2, which is integrate both sides. So you will have the integration of d theta. Again, remember, when it's just d theta, that basically means it's 1 d theta is equal to the integration of minus 5 over 2t plus t times dt. Integrating 1 in terms of theta is going to be just theta is equal to, integration over here is negative 5 over 2. And then it's as if it's negative 5 over 2. If I want to rewrite this, this is negative 5 over 2 times 1 over t. All right, it's the same thing. I need this first part. It is as if you're saying it's negative 5 over 2, which is a constant, which isn't affected by integration, times 1 over t. The integration of 1 over t is ln of absolute value of t plus t. All right, all of this dt. This is basically the same thing. All right, so it's going to be plus the integration of t, which is t squared over 2 plus c. Again, we have done a lot of integration before. You guys should practice your integrations. Once you know how to, once you got this, this is going to be your final answer now. In the case if you have an initial value problem, so this is if you're not given any initial values. What if they say theta of 1 is equal to 2? So what does this mean when they give you this as an initial condition? So this is an initial condition. This basically means that when t is equal to 1, theta is equal to 2. This is what it basically means. So a function of t, theta, زين يوم يساوي 1 معناته time when it's equal to 1, or t, whatever t represents, is equal to 1, is going to be equal to 2. يعني theta is equal to 2 when t is equal to 1. And now we can plug it in back into our equation. So theta is equal to 2 will be 2 is equal to minus 5 over 2 ln absolute value of 1, which is our t value, plus t squared, which is 1 squared over 2, plus c. Okay? And now you just solve for c. So what do? Simplify it. So ln 1 is 0. If you don't know this, you can just use your calculator. The ln of 1 is 0. So this is 0 plus 1 squared is 1 over 2 plus c. 2 minus half is equal to c. معناته our c is equal to 2 minus half, which is 3 over 2. And now your final step is plugging c back into the c value over here in our original equation. So the final value would be, for an initial value problem, is the same as solution plus c, which is 3 over 2. Okay? This is how you would solve it up to here, up to this point. This is a correct answer if you are not given initial conditions. If you are given initial conditions such as here, all right, then you're going to have to plug in these values into the equation to find your c value, and then plug it in back into your original equation to get your final solution. Okay? Now, what about if we had something like this, that we had both variables? So let's say we had dy by dx is equal to 2 times x times y. So in this case now we have dy and dx, and we have two variables x and y. And from now I'm telling you the initial conditions is y equals y of 0 equal to. Remember, all this means is the 0 here is x is equal to 0, and this value 2 over here is y is equal to 2. Okay, so when x is equal to 0, y is equal to 2. That's what this means. So first step is separation. Separation. So how do we separate this? dy, we will take the x to the other side, is equal to 2xy dx. All right? But we are not done here. Yes, dy and dx are separated, but now you need to separate your y from your x. So x has to be separated from y. All right? The x has to be with the dx, and the y needs to be with the dy. So we're going to have to divide both sides by y so that the y can go to the other side, and here the y's will cancel. So you will get dy by y is equal to 2x dx. All right? Another way of writing this equation can be 1 over y dy. Okay? Because remember, at the top here, it's as if it's 1 times dy. Okay? So we could separate the dy, keep it outside, so it's a bit more clear. is equal to 2x dx. Now that we have separated and we have all our y values with y and x with x, so here x and dx, and here we have our y with dy, we can solve for this equation. How would we solve? Our second step is integration. So now we have to integrate both sides. So the first one will be the integration of 1 over y dy is equal to the integration of 2x times dx. Integrating will give us 1 over y. The integration of 1 over y or 1 over x is ln absolute y is equal to the integration of 2x dx. So how would you integrate this? 2x squared divided by 2 plus c. All right? But notice here that we have ln of y. We do not have y is equal to something. We have ln of y. How can we get rid of the ln in this case? The way to do this in math is by applying the exponential, if you remember from before, which is e to the power, basically. Okay? So this is our exponential. How does it apply here? So if we raise e to the power of ln absolute y on the left, we do the same on the right, e to the power of 2x squared, which is just x squared, right? Because the 2 and the 2 will cancel. And then outside you will have plus c. Your c value, keep it as plus c at the end by itself. Do not do e to the power or anything. You could just leave it as plus c until the very end when you want to solve for it, or if you just want to keep it the way it is. All right, because it's a constant. It doesn't matter the value of it. It's just a constant. Okay. So when we do e to the power of ln y, what happens here is the rule is e to the power of ln will cancel out each other, and you will be remaining with y. So y will be equal to e to the power of x squared plus c. And this is your actual solution. However, we have a c value and we were given initial conditions, which is when x equals 0, y is equal to 2. All right? So these are our initial conditions. When you are given initial conditions, the problem is known as an initial value problem. So I'm just going to write this down here so you guys don't get confused. If the question says this is an initial or solve the initial value problem, معناته you are given initial values or initial conditions. That's all this means. So how do you solve? Again, you just substitute your values for both. So y is 2, 2 is equal to e to the power of 0. Y of 0, yeah, e to the power of 0 squared plus c. Okay? Meaning, if we have 2, okay, so if we have 2, this is going to be 2 is equal to e to the power of 0, which is just e to the power of anything to the power of 0 is just 1 plus c. معناته c is equal to 2 minus 1. In other words, c is equal to 1. So the solution here would be, you would take back this equation again, and you will just plug in c in its place. So c is equal to 1. So this is going to be plus 1. And this is your final solution for these initial conditions. Is that clear? And that's pretty much it for ordinary differential equations. All you have to do is you make sure you know your integration very well. So always the first step would be separation. The way you separate is you want dx and dy to be by themselves, and any x's to be with your dx, any y's to be with your dy's. So in this case here, what did we do? We first took our dx to the other side. So it became like that. So first thing we did was take this over here, and then we got 2xy dx and dy on the left side. Then we wanted to take the y to the other side because we want the y to be with the dy. So we divided both sides by y. And then we got this equation over here where we have our dy's together and our x and dx together. Then when you have that case, you can just integrate directly to find your actual values for y and x. Once you find your actual values for y and x, you simplify for y so that the equation will only have y on the left side, والباقي بيكون on the right side. If you have an initial value problem, بما معناه if you are given initial conditions, you're going to be substituting the values of your initial conditions, in this case x equals 0 and y equal 2, into your equation. Once you substitute that, you will find the value for c. In this case, we found 1. And then we're going to be plugging this back into our equation in place of c, and you will get your actual final answer. Okay?